Okay, so are you able to see the screen?
Yes.
Okay, thank you. So once again, I welcome you to the week 6 of the live sessions for the course Basics of Finite Element Analysis Part 2. The course instructor, as you might know, is Professor Dr. Nachiketa Tiwari from IIT Kanpur. Introducing myself once again, I am Vikram Balaji, a research scholar from the Department of Mechanical Engineering at IIT Madras. So this is the week 6 of the live sessions. So there are totally 8 sessions, as you may know. So we are going into the 6th session. So if you can recall, so these are the major topics of the week 6 lecture contents. So what we might have seen is, so first of all, we might have seen about the interpolation function for triangular and rectangular elements. This is for two-dimensional finite element problems with a single variable. So we might have seen what are the interpolation functions for triangular and rectangular elements. And second, we also saw about stiffness and force matrices for triangular and rectangular elements. And the next major topic is deals with the boundary integrals for the triangular elements. Okay, so with this we will now move into the assignment questions. So the assignment questions will be a mixture of both subjective and objective questions. The sample assignment questions which we are going to see in this session. So we'll let us now move into the questions. Okay, so this is the first question. So if the interpolation functions for linear triangular element can be expressed in the following manner. So psi is your interpolation function. So corresponding to three nodes, there are three interpolation function. So in general, the psi I, if it can be defined in the following manner. So 1 by 2a into alpha I plus beta I x plus gamma I y. So a here represents the area of the element, so which is the area of this triangle. So the sum alpha I, what does it represent? So I equal to 1 to 3 or alpha I, that means your alpha 1 plus alpha 2 plus alpha 3. So what is that sum equal to? So and the four options are given here. So first option is 0, option A is 0, option B is 1, option C is A, option D is 2A. So are you aware of what are the alpha, beta, gamma for a shape function for the linear triangular element? So if you are aware, you can simply just take the sum of alpha 1 plus alpha 2 plus alpha 3. So can you quickly work it out and tell me what is the answer? If you are not aware, we can solve this problem, not an issue. So are you aware, or shall we solve the problem?
If you solve it, it will be better, I think.
Okay, so okay, we'll solve it, no problem. So first of all, we'll see how the shape functions come into picture. So I'll take this note, I will use this note for doing that. So you might have seen in the last session also, we tried to derive the shape function for a general triangle. So this was the coordinates x1 y1, this is x2 y2, and here x3 y3. So this I am numbering it as 1, 2 and 3. So for the displacement inside this of any point within this domain, we define it like this for linear triangular element. So my u is going to be, let us say it is going to be c1 plus c2x plus c3y. So which means it's a function of both x and y, and I have three constants. So how I am going to determine these three constants? I am going to simply plug in my value at x equal to x1 and y equal to y1. My u is going to be u1, and similarly at x equal to x2 and y equal to y2, my u is going to be u2, which is corresponding to the displacement of the second node. And similarly I can substitute and find the displacement of the third node. So I can generate three equations like this. So my u1 is going to be c1 plus c2 x1 plus c3 y1. My u2 is going to be c2 plus, sorry, not c2, going to be C1. Could be C1 plus C2 x2 plus C3 y2. My U3 is going to be C1 plus C2 x3 plus C3 y3. So this is going to be my three equations. So these three equations I am going to represent in the matrix form like this. So which is going to be I have U1, U2, U3 at one side. So I have 1 x1 y1, 1 x2 y2, 1 x3 y3. So like this I have C2 C3. So till here is there any doubt? So I just
No
yes,
doubt.
okay. So I just represented a linear triangular element, the displacement function I represented in this way, and with this I just substituted the 3 points and I generated three equations. So how I am going to get C1, C2, C3? That I am simply going to take the inverse of this. So this is going to be my U is equal to some A into C. So my C matrix is going to be some A inverse into U. So if I represent this C1, C2, C3 is going to be 1, 1, x1, x2, x3, y1, y2, y3, the whole inverse into u1, u2, u3. So this you might have seen in the last session also. So how to take the inverse of this matrix? It is for 3 by 3 matrix it is simple. So inverse is basically adjoint by determinant, adjoint matrix by determinant. Okay, so if you try to simplify, you will get something of this form. So what my question was, you will get like this, right? So how to get in that form? So my C I have to do like this. So let me try to take the inverse of this matrix. So adjoint matrix, how do you find? First you have to find the cofactor matrix and then you have to take the transpose of that. So I hope you are aware of how to find a 3 by 3 inverse of a 3 cross 3 matrix. So what is cofactor means? So let me say it is a C. So C11. So C11 how do I find? I have to ignore the so for this element what is the cofactor? So how I do is I delete these two elements and I multiply these two. So what will I get? I will get something like x2 y3 minus x3 y2. So similarly for C12, what should I do? I will erase this. So for this, for what is my cofactor? So I delete these corresponding row elements and these elements, and for these two elements I do the multiplication, cross multiplication. So what I get is y3 minus y2, correct? So any doubt in the cofactor till now?
No doubt.
Yeah. Okay, so like this I can keep doing. So C13 I can write. So what will that be? Means if I have to for this one y1 element, so I delete these two elements I delete and I simply do the cross multiplication for these two.
x3 minus x2.
Yeah. So it will be x3 minus x2. So similarly I can keep doing. So I will quickly generalize for C21. For C21 what it will be? You can say it will be x1 y3 minus x3 y1. C22 is going to be, so I can say that it will be y3
minus y1.
Yes, y3 minus y1. Okay, so I have to do the signs accordingly. So I forgot to put the sign. So this will be plus minus plus minus plus minus plus minus plus. So for 1 1 it is positive. So 1 2 it will be negative. For 1 3 again it's positive. For 2 1 it will be negative.
Then
So this is positive. Okay. And first I can keep writing. So this will be negative, this will be positive, this will be negative, this will be positive. So for C23 it will be if you ignore this row and this column, it will be x3 minus x1. So minus of, okay. For C31 it will going to be x1 y2 minus x2 y1. For C32 it is going to be y2 minus y1, minus of y2 minus y1. For C33 it is going to be x2 minus x1. Okay, so I can write this cofactor matrix. My cofactor will be C11. So this will be my cofactor matrix. So what is my adjoint matrix? How will I get adjoint?
transpose.
Yes, you have to transpose. So which means it will be become like this. So I'm going to write all the matrices, like all the elements I can write. So it is going to be x2 y3 minus x3 y2. So C21 is going to be negative of this. So it will be x3 y1 x1 y3 and C31 is going to be x1 y2 minus x2 y1. So what is C12? Minus of y3 minus y2. I am going to write it as y2 minus y3. What is C22? y3 minus y1. C32 minus of y2 minus y1. I am going to write it as y1 minus y2. Okay. So what is C13? It is x3 minus x2. I am simply going to write it as minus of x2 minus x3. So why I am writing this way is so that this 2 and 3 is it will be corresponding in both the sides. So what is C23 minus of x3 minus x1, and what is final C33 x2 minus x1. I am going to write as minus of x1 minus x2. So this is my adjoint. So adjoint you have got. Then what is the determinant? The determinant we can simply write it as modulus of A. So modulus of not A. So yes, whatever the matrix name which I kept earlier. So I kept it as A matrix. So modulus of A. So
Laplace expansion.
yeah. So if I, so this determinant will be nothing but 2 times the area of the triangle. Is it correct? Yes. So this I can make it as some 2a. So I am making area of triangle as a. So finally my inverse is going to be, so area of element I will say. So 1 by 2 times AE. So I am going to get something like this. So this matrix, entire matrix, I am going to make it. So I will simply make it as this is alpha 1, alpha 2, alpha 3. This is beta 1, beta 2, beta
What
3.
is AE?
Area of the triangle.
Oh, okay.
Yeah. So if you evaluate this determinant and if you divide by 2, you will get the area of the triangle, right? So yes. So just I am mentioning as 2 times of area of triangle. So these terms I am mentioning as alpha 1, alpha 2, alpha 3. Similarly, this will be my beta 1, beta 2, beta 3. This will be my gamma 1, gamma 2, gamma 3. So this we would have already seen in lecture. So once again I am writing here. So what was our question is, sorry, so our psi, so now we have to represent our psi. So now we got A inverse, so we have to multiply this A inverse with U. So my C1, C2, C3 is going to be, so this A inverse I am writing as 1 by 2 AE, alpha 1, alpha 2, alpha 3, beta 1, beta 2, beta 3, gamma 1, gamma 2, gamma 3 into U1, U2, U3. So if I multiply, I am going to get in this form. So I can multiply the first row with the first this column. So if I will get C1 is equal to 1 by 2 AE into alpha 1 U1 plus alpha 2 U2 plus alpha 3 U3. Similarly, C2 I am going to get 1 by 2 AE into beta 1 U1 plus beta 2 U2 plus beta 3 U3. C3 I am going to get 1 by 2 AE into gamma 1 U1 plus gamma 2 U2 plus gamma 3 U3. So like this I have got C1, C2 and C3 I finally got. Now I am going to in the very first equation which we mentioned, I am going to simply just substitute these values. So my U is going to be C1 plus C2x plus C3y. So which is equal to, I am going to substitute these values. So 1 by 2 AE alpha 1 U1 plus alpha 2 U2 plus alpha 3 U3 plus, I will just multiply x here, x by 2 AE beta 1 U1 plus beta 2 U2 plus beta 3 U3, and finally and plus y by 2 AE into gamma 1 U1 plus gamma 2 U2 plus gamma 3 U3. Okay. So if I represent, you can represent in this fashion. So 1 by 2 AE to alpha 1 plus beta 1x plus gamma 1y into U1 plus 1 by 2 AE into alpha 2 plus beta 2x plus gamma 2y into U2. So which means what I am doing is, wherever there are U1, I am going to simply collect that coefficients. So this will be one coefficient, then this will be one coefficient, and this will be one coefficient. So I am grouping this together. So if it will be alpha 1 plus beta 1 times x plus gamma 1 times y into this 1 by 2a into U1. Similarly for U2 and U3 I am also grouping together. So when I group, if I let's say this color means, so this will come, so this will come and this will come, and for gamma and for U3 these three terms, and along with this 2AE also, and this x and y. So I will again write it 1 by 2 AE alpha 3 plus beta 3x plus gamma 3y into U3. So this is going to be my first step function psi 1. This whole term is going to be psi 2. This whole term is going to be psi 3. So psi 1, psi 2, psi 3, that formula is very similar, so I can generalize it as some psi I. Some psi I you can say 1 by 2 AE into alpha I plus beta I x plus gamma I y. So what is my alpha I, beta I, gamma I? So we know that alpha 1, beta 1, gamma 1 we found it over here. So this was our alpha 1, alpha 2, alpha 3, beta 1, beta 2, beta 3, and gamma 1, gamma 2, gamma 3. So like this we generalized. So if you want to generalize for alpha I can write it as some xj into yk minus xk into yj. So how this is going to work means, let us say I, j, k. So it's in a circular fashion. Sorry, I will write it as like this. So 1, 2, 3, correct. So if it's going to be go like in a circular fashion only. So if I choose I as 1, so my j will be 2 and k will be 3. So now if I choose this as I as 2, so this will become my j and this will become my k. And if I use this as I is equal to 3, and my j will become 1 and k will become 2. So like this cyclic we can go. So by this I can represent a general formulation. So alpha is equal to like this. Similarly beta I can write it as yj minus yk, and gamma I can write it as minus of xj minus xk. So this entire formula I am just generalizing. So whatever we wrote here in this I have generalized. So like this we have achieved now. So this is what our question is also. So alpha I plus beta ix plus gamma I y. So what is the sum of alpha I is the question. So sum of alpha I is nothing but alpha 1 plus alpha 2 plus alpha 3. Okay. So what is alpha 1 plus alpha 2 plus alpha 3? So alpha 1 is nothing but x2 y3 minus x3 y2 plus alpha 2 is x3 y1 minus x1 y3 plus x1 y2 minus x2 y1. So what is this value? Can anybody tell? So if you observe this determinant and try to expand it, yeah, it will be 2 into area, this one. So our answer should be option D, right? So answer is option D. So this is how we found out the sum of alpha I. So with this we'll see some few more questions. So it will be related to the same problem. So for the same problem, now I want sum of beta I and gamma I. So can you calculate and tell what will be the answer?
Repeat once again.
So last question, any doubt is there? We solved alpha sum, no? So did you have any problem, any doubt in that?
No.
Yeah, this is okay, right? So again, so same question, instead of alpha I want sum of beta 1 plus beta 2 plus beta 3, and similarly gamma 1 plus gamma 2 plus gamma 3. So what are that sum equal to? So last question we saw that it was equal to 2a.
I think again it will be 2a.
It will be 2a. Okay. So did you try to did you solve it or are you guessing? So we just solved what is beta and gamma, right? So you can try to sum everything and we can see what will be the answer.
I think that if we go through a row or column,
Yeah.
we get the 2 times area of a triangle.
Yes, correct.
From that point of view, I guess it may be 2a.
Oh, okay. So but this is 2a we saw. So what was our summation of beta I is our question, right? So this is going to be beta 1 plus beta 2 plus beta 3. So we'll just substitute what is beta 1, beta 2, beta 3. Yes. So I'll just simply write for this case of clarity. So y2 minus y3, this will be y3 minus y1, this will be y1 minus y2. So you can see all the terms are cancelling each other. So essentially we will get as 0. Similarly, you can try for gamma I also. That will also be 0. So for clarity purpose, I will simply expand one and write. So
right, because in color
yeah,
there is 1 1 1.
yeah, yes, correct. So if you expand it, okay, this will be minus x2 plus x3, no? Minus now this will be plus, this will be minus. So here also you can see all terms are cancelling each other. Final answer is 0. So for this question, the answer is option A, 0. So yes, answer is option A. Again for the same question, we will try one more problem. So here the question is, if the interpolation function can be represented in the following manner, so what is the summation of psi I? So can you try this? So we have the formula of psi I already. So you can simply substitute psi equal to 1, I equal to 2, I equal to 3, and you can try to solve this. So I'll maybe give some few time for you to solve. So parallelly I will also try to keep solving. So if you get the answer, you please inform in the middle. So we will try to solve this now. So my psi I is nothing but 1 by 2a into alpha I plus beta I x plus gamma I y. So if I simply try to sum psi I, so I am going to get 1 by 2a into this will get summed up, and similarly my x will be common, and similarly here the y will be common. Okay. So can you tell the answer now? So you can see that we have individually solved these answers. So summation of alpha we have seen, summation of beta we have seen, summation of gamma we have seen. So from here, can you calculate and tell the answer of what will be the summation of psi I? Yeah, correct. So answer is B. So for the sake of clarity, I will again try to expand. So we saw that in the first question, summation of alpha I was 2a, summation of beta I will become 0. So this term vanishes, and similarly this also vanishes because summation of gamma I is 0. So which means 2a by 2a. So my answer is 1. Okay. So this was question 3. Again one more question with the same background. So we have to find this term. So for any I we can say. So what is my summation of alpha I plus beta I x cap plus gamma I y cap? So x cap I have defined here. It is nothing but 1 by 3 into summation of xi, and y cap is nothing but 1 by 3 into summation of yi. So again we'll have to work this out. So we'll try working out this problem also. So what is being asked here is, alpha I plus beta I x cap plus gamma I y cap for any I. So let us take I is equal to 1. So alpha 1 plus beta 1 x cap plus gamma 1 y cap. So what is my alpha 1? x2 y3 minus x3 y2. Beta 1 is y2 minus y3. Gamma 1 is minus of x2 minus x3. And x cap is going to be 1 by 3 times x1 plus x2 plus x3. So that is my definition. So summation of x divided by 3, xi divided by 3, and this will be y cap will be summation of y1 plus y2 plus y3 divided by 3. So now I simply have to substitute everything. So alpha 1 is x2 y3 minus x3 y2 plus beta 1 is y2 minus y3 into x1 plus x2 plus x3 by 3 minus x2 minus x3 into y1 plus y2 plus y3 by 3. Okay, so I think somebody's mic is on, so it is I think some sound is getting. So if anybody has switched on the mic, I request you to, for temporarily you can switch off. So when you want to answer, you can please switch on and tell the answer. So thanks. So if I try to sum this up, it will be x2 y3 minus x3 y2. So I'll just simply multiply. So what I'll get is x1 y2 by 3 plus x2 y2 by 3 plus x3 y2 by 3 minus x1 y3 by 3 minus x2 y3 by 3 minus x3 y3 by 3. This will be, so this term I have expanded. So please check if I am right. So if there is any mistake, you can please correct me. So I have expanded. So now I am going to expand this term. So it will be minus x2 y1 by 3 minus x2 y2 by 3 minus x2 y3 by 3 plus x3 y1 by 3 plus x3 y2 by 3 plus x3 y3 by 3. Okay, so x3 y3 by 3, I'll just cancel out what are the terms which are cancelling each other. So this one and this one will get cancelled. So I think rest of the things we can try to see. So I'll just group the similar terms. x2 y3 is occurring here, and similarly one x2 y3 by 3 is occurring here. Similarly one x2 y3 by 3 is occurring here. So I will just underline the similar terms. So maybe we will see for x3 y2 here and here and here. So it's coming minus x3 y2 plus x3 y2 by 3 plus x3 y2 by 3. Again x1 y2, this occurs once, and x3 y1 also occurs once. So plus, okay, I'll choose the black color. x3 y1 by 3 minus x1 y3 by 3. So from here, then plus x1 y2 by 3 minus x2 y1 by 3. So this will become 1 minus 1 by 3 minus 1 by 3. So 1 minus 2 by 3, which is going to be 1 by 3. So x2 y3 by 3 minus x3 y2 by 3. So this also minus 1 plus 1 by 3 plus 1 by 3. So this will become minus 1 by 3. So again here, so which means I have combined these three terms, and then I have combined these three terms. So rest I am going to write as it is. So if I take 1 by 3 as common, so you will get one term in the numerator. So can you tell what is this term? So we have seen this term, right? So this is nothing but 2 into area, and denominator you have 3. Yeah. So here, so we have one option which is 2a by 3. So you see, yes, the option is C. You can, I have tried for I equal to 1. If you try for I equal to 2 and I equal to 3, you will see that you will get the same answer. So maybe I will leave it for you to try, or probably I can do one of them, or maybe we will leave it. So for I equal to 1 we checked it is 2a by 3. If you check for any I, it will be equal to the same value. So that is one of the properties of this shape functions. So we have seen now about triangular shape function for the linear triangular element. So now we'll go to the linear rectangular element. So I have a question. So if psi I x comma y represents the interpolation functions for a linear rectangular element shown, then what is the summation of I is equal to 1 to 4 dou psi I by dou x? So this is my question. So again, if you know the answer already, you can answer, or else we will try to solve this problem also step by step. So here we have a rectangle, so with 4 nodes. So this is a bilinear, you can say, or you can say it's a linear rectangular element with sides a and b. So usually what we do in a rectangular element is we try to define a new coordinate system, which is x bar, and this will be y bar. So what is my relation between x bar and y bar? I can write it this way. So I will go to the nodes. So this is my xy coordinate system first of all. So I have a rectangle. Okay. So this is my x1 comma y1, x2 comma y2, x3 comma y3, x4 comma y4. So if I insert a new coordinate system like this, which is nothing but I am simply shifting this coordinate system to this here. So this will be my x1, this will be my y1. So what is the relationship between x bar and x? So x is nothing but x bar plus x1. So x bar is here, and if you add an x1 you will get an x. So again y is equal to y bar plus y1. So here if you see, so if you make this side as a and this side as b, so in my x bar y bar I can simply write in this fashion. So I am going to write what are my nodes 1, 2, 3, 4. So here it is going to be my x1 comma y1, and correspondingly in this will be 0 comma 0. This will be 0 comma 0. This will be I think a comma 0. This will be 0 comma b, and this will be a comma b in the new coordinate system. So I am simply going to write this as a table. x2 comma y2 is going to be a comma 0, x3 comma y3 is going to be a comma b, x4 comma y4 is going to be 0 comma b. So this is my table of coordinate mapping from the xy to the x bar y bar. So in the x bar y bar I can represent my primary variable u. It is going to be, let us say, c1 plus c2 x bar plus c3 y bar plus c4 x bar y bar. So this is going to be my, I can call this bilinear representation. So we might have seen this in the last session also. So I'm again repeating. So this is my expression. So I'm going to simply substitute these 4 points one by one and going to generate V1. So U1 is equal to C1 plus C2 times of x bar is, you can say, 0 0. This also 0. So this is nothing but C1. So my C1 is nothing but U1. Simple. So we got one equation. So next equation, U2 is equal to C1 plus C2 times of A plus C3 times of 0 plus C4 times A into 0. So I am simply substituting these points one by one and I am getting the constants. So my U2 becomes C1 plus C2 times of A. So these terms will vanish. So what is C2? U2 minus C1 by A. So C1 is nothing but U1. So C2 is nothing but U2 minus U1 by A. So this is my second equation. So let me go for third equation. U3 is equal to C1 plus C2A plus C3B plus C4AB. This is third equation. So since we do not know C3, C4, I will simply go to the fourth equation. We will see, I have to simply substitute 0 comma B. So which means C1 plus C2 into 0 plus C3 into B plus C4 into 0 into B. So this I can evaluate. U4 is equal to C1 plus C3B. Correct? So C3 is equal to U4 minus C1 by B. So C1 we already saw, it is going to be U1. So you can simply write C3 as U4 minus U1 by B. So now these 3 I can substitute 1, 2 and 3 in the U3 equation. So C1, C2, C3 I can substitute, I can get the C4 now. So from that equation, if you see, C4 is nothing but U3 minus, so except this term I am all bringing all the to the left hand side, U3 minus C1 minus C2A minus C3B by AB. Correct? First I bring all the terms to the left hand side, then AB I divide both sides so that C4 remains in the one side. So like this. So simply have to substitute everything now. U3, C1 is U1, C2 is U2 minus U1 by A into A, and again C3 will be U4 minus U1 by B into B. The whole thing divided by AB. So C4 is nothing but U3 minus U1. So minus U2 plus U1 minus U4 plus U1. So this thing will cancel, whole divided by AB. So C4 U1 minus U2 plus U3 minus U4, the whole divided by AB. So this is my fourth equation. So we have seen this all this in the last session also, and in the lectures also sir might have dealt with this. So till here I hope there is no doubt. Is there any doubt in how we derived the C1, C2, C3, C4?
No, sir.
Okay. So we'll directly go to the formula now. U is C1 plus C2x bar plus C3y bar plus C4 x bar y bar. So C1 is nothing but U1, C2 is U2 minus U1 by A into x bar, plus this will be U4 minus U1 by B to y bar, plus this whole thing U1 minus U2 plus U3 minus U4 by AB into x bar y bar. So I am going to group all the U1 terms together first. So there is 1 here, and there is minus u1 by a, minus 1 by a into x bar, and then there is minus 1 by b into y bar, and then here there is this one. So my u1 will be 1 minus x bar by a, then from here it will be y bar by b, from here it will be x bar y bar by ab. This whole thing is going to be into u1. Then u2, again we can see what are the terms common. So one term is x bar by a here, and from here minus this term. So x bar by a positive u2, then it will be minus x bar y bar by ab into u2. So u3 there is only one term throughout, it's only x bar y bar by ab. For u4 there are two terms, one is y bar by b, then again from here minus x bar y bar by ab, u4. I'll further simplify this. So first of all, before simplifying, we'll just see that this is going to be my psi 1, this is going to be my psi 2, this is going to be my psi 3, this is going to be my psi 4. So corresponding to the nodal function, nodal value u1, u2, u3, u4, we have the corresponding shape function psi 1, psi 2, psi 3 and psi 4. So finally my psi 1 is 1 minus x bar by a minus y bar by b plus x bar y bar by ab. So if I further simplify, 1 minus x bar by a minus y bar by b, if I take common, I will get 1 minus x bar by a. Again if I take this 1 minus x bar by a as common, and I will get 1 minus y bar by b. So this is my psi 1. Okay. What is my psi 2? Psi 2 is x bar by a minus x bar y bar by ab. So if I take x bar by a as common, 1 minus y bar by b. Psi 3 simply x bar by a into y bar by b. Psi 4, if you observe, it will be y bar by a into, sorry, not y bar by a, y bar by b. One minus x bar by a. So we have found out all the four psis, and these are in the x bar y bar coordinate system. So psi 1, psi 2, psi 3, psi 4 found. We will now go back to the question. What we'll see what was asked. So summation of dou psi I by dou x. So we have seen in the x bar term. So let us see how to. So my x is nothing but x bar plus x1. We saw already. I'll write this in black. X is equal to x bar plus x1. Y is equal to y bar plus y1. Okay. This I am just reiterating this. These two I am just simply writing it again. So this is related to shift in the coordinate system. So if you take dx from here, it will simply be dx bar, because x1 is a constant and similarly y1 is a constant. So my dy will also be dy bar. So this, okay, this is fine. Now what will be my dou psi by dou x? So it will be, I am using the chain rule. So dou psi by dou x bar into dou x bar by dou x. So any doubt here? So I just used the chain rule for differentiation. So but we have just derived that dx is equal to dx bar. So this will be 1. So which means my dou psi by dou x is the same as dou psi by dou x bar. Which means I can just simply differentiate in the x bar coordinate system. That will be same as differentiating in the x coordinate system also. So essentially what I am going to do, I am going to differentiate each of the 4 functions with respect to x, and simply I am going to add them. So what is dou psi 1 by dou x? Now dou psi 1 by, so dou x bar I will write, it is nothing but same as dou x only, just we have seen now, which is nothing but dou by dou x bar of this whole thing, 1 minus x bar by a into 1 minus y bar by b. So if I expand it, so if I differentiate this term, these first 2 terms will vanish. I will get minus 1 by a for this, and I will get plus y bar by ab, because with respect to when I differentiate, partially differentiating with respect to x, my y bar term remains constant. So this will be my dou psi 1 by dou x bar. Okay. So what is dou psi 2 by dou x bar? Dou by dou x bar of x bar by a into 1 minus y bar by b. So you can simply check out the previous one. So I have just taken this I2, I will expand it inside. So if I do this, I will get 1 by a minus y bar by ab. Okay. This is psi 2, dou psi 2 by dou x. Next is dou psi 3 by dou x. I am doing for dou x bar, which means that it is essentially the same as dou x only. So dou by dou x of x bar y bar by ab. So this is simply going to be y bar by ab. Since we are partially differentiating with respect to x, y can be treated as a constant. So now dou psi 4 by dou x is equal to dou by dou x bar of y bar by b into 1 minus x bar by a. So if I expand it, y bar by b minus x bar y bar by ab. So this will vanish because y is treated as constant, and here I will just, the coefficient will be minus y bar by ab. Okay. So now I have simply got to add everything. Summation dou psi I by dou x. So I am going to add everything. The first one was minus 1 by a y bar by ab. The second one is plus 1 by a minus y bar by ab. Third one is plus y bar by ab. Fourth one is minus y bar by ab. So what is the sum? This term cancels out. This also cancels out. This also cancels out. So my answer is 0. So you can see here. So I have an option A which is 0. So this is what I have got. So if you see, yes, the answer is again is 0. So we have solved this question. So in this question, any doubt in how I solved it? So I simply found out what are the shape functions, and then it simply differentiated with respect to x bar. And I told that when I differentiated x bar, it is same as differentiating with x, because from the chain rule we observe that dou psi by dou x is same as dou psi by dou x bar. So my question may be related to dou psi by dou x, but still you can do it this way, and you can say that my answer is 0. So any doubt in this question?
Yes, sir.
Okay. So we will go to the next one. Okay. So we have this right angled linear triangular element. So I missed the element. So it should be here, element shown below. So determine the element stiffness matrix associated with the Poisson's equation. So this is the Poisson's equation which is given. So how to determine the element stiffness matrices? First we need to do this, take the weak form, then do this thing. First we have to do the weighted residual integral and then derive the weak form. So again they are assuming a11 and a12 are constants, and also evaluate the element stiffness matrix for the conditions a11 is equal to a22 is equal to k and a is equal to b. Okay, so this is our question and this is the triangle. So you can see here my base is a and my height is b. So if I want to simply do the coordinates, so this will be 0 comma 0, so this will be a comma 0 and this will be 0 comma b, right? So we'll see this question, we'll again go back to my notes and we'll try to solve this elaborately. So I have this, this is my triangular domain which is x and y. So incidentally if you see, it is coincidental with the axis 0 0 comma b. So this is my node 1, this is my node 2, this is my node 3. The base was a and height was b. So accordingly I have derived the coordinates. So my x1 y1 is nothing but 0 comma 0, x2 y2 is a comma 0, x3 y3 is 0 comma b. So in the previous questions we already derived the shape functions. So I'll simply write what is the shape function. So 1 by 2 times of area of the triangle. So area is nothing but, you can simply say half into base into height, or else you can simply do the determinant also and find out, but you will find out that it will be equal to this half into base into height. So we already know. So 1 by 2a into alpha I plus beta I x plus gamma I y. So alpha, beta, gamma we have already seen the formulas in the previous question. So what we have is, we have this Poisson's equation. So what I will do is, I will write the general model equation, I will derive the weak form and then we will simplify it into the Poisson's equation. So if you can recall the model equation which we might have learnt in the classes. So model equation is, you can say it's like this, minus dou by dou x of a11 dou u by dou x plus a12 dou u by dou y plus, minus dou by dou y of a21 dou u by dou x plus a22 dou u by dou y plus a00 into u minus f is equal to 0. So this is my model equation. If you want to convert this model equation into this Poisson's equation, so essentially what happens is, my a12 and a21 becomes 0. So these two will vanish and my a00 will also be equal to 0. So this is how I will get the Poisson's equation. But what we will do is, we will try to solve the weak form for the entire model equation, and in the end we will substitute these values of a12, a21 and a00. Okay, so any doubt till here? So I have just written the model equation. So we will see how to develop the weak form of this equation and develop the element stiffness matrix. So if you have any doubt, please ask in the between, I will clarify once again. So first step is, I have the domain and I have the element also. So the domain is already discretized. So which means that this is my discretization. I have a single element, linear triangular element. So this is my domain. The second step is, I have to perform a weighted residual integral. So which means that I have this equation, I am simply going to w into this equation and integrate over the domain is equal to 0 over the element. So to simplify this equation, I will make this term as f1 and I will make this whole term as f2. So my equation now becomes dou f1 by dou x minus dou f2 by dou y plus a00 into u minus f is equal to 0. So this equation, entire equation, I am simply going to do the weighted integral, weighted residual integral, which means over this domain, which is the element, I can say w into minus dou f1 by dou x minus dou f2 by dou y plus a00 u minus f into d omega equal to 0. So d omega is nothing but the integral over integrating over the domain. So in our case d omega is nothing but dx dy, since there are two coordinates, and this represents the element, the infinitesimal area. So I will now just split these things. So for first integral I will take the minus outside, so it will become w times of dou f1 by dou x plus dou f2 by dou y. So common, I have clubbed these two terms and take the minus outside, so it becomes this thing. So this will become, so into d omega. So then you have plus a times of 0 0 into u into w into d omega minus f w d omega is equal to 0. So what I am going to do, I will take this into this side. So I will just put an equal to sign here, and I will remove this 0. So simply I am taken this f to the other side. So we have this thing now. So what is w times dou f1 by dou x? I'll use a different ink for this. What is this? So if you have like this, say d by dou x of w times of f1, so I can use chain rule. It will become w times dou f1 by dou x plus f1 dou w by dou x. So why I am doing this? I am trying to reduce the integration requirement, which means I am now expressing in the weak form, which means I am reducing the differentiability requirement for f1 by doing this chain rule. So if I now I can say my w of dou f1 by dou x is equal to dou by dou x of w f1 minus f1 dou w by dou x. So similarly, what is w dou f2 by dou y? So dou by dou y of w f2 is equal to w dou f2 by dou y minus f2 dou w by dou y. So my w dou f2 by dou y is equal to dou by dou y of w f2 minus f2 dou w by dou y. So I just substitute these two things into here. So I changed back to black now. So what will this become? So minus of w dou f1 by dou x minus of w dou f2 by dou x. It is going to become simply over the domain f1 dou w by dou x plus f2 dou w by dou y, and this will become minus dou by dou x of w f1 minus dou by dou y of w f2. This whole thing into domain. So this, from this term I have come to this term by the chain rule, and what is remaining now? Plus a00 uw d omega is equal to w f d omega from over the integral. Okay, so I am going to split this into two once again. I am going to retain this f1 dou w by dou x plus f2 dou w by dou y into d omega. This I am going to keep it one side, and minus the other side I am going to keep dou by dou x of wf1 plus dou by dou y of wf2, this whole thing into d omega. And plus a00 uw d omega is equal to wf d omega. So once again, this term I am going to use the divergence theorem. So what is divergence theorem? First of all, this term I can represent it this way. So dou by dou x of wf1 plus dou by dou y of wf2. So I can represent it as my dou by dou x I cap plus dou by dou y of j cap dot product with wf1 I cap plus wf2 j cap. So this is nothing but my gradient operator dot product with wf vector. So what is my integral of gradient over the domain? So divergence theorem, can anybody recall what will be the value in the RHS? So I have a gradient of a vector over the domain I am integrating. So what will be the here right hand side? Can anybody recall? So this is a volume integral, right? So what will be the right hand side? So I can relate the volume integral, or I can say domain integral, into the boundary integral. So can you recall that? So this will be over the boundary my wf dot n vector into ds. So this is my divergence theorem. So here n is nothing but nx plus ny. So what is my wf dot n, which means wf1 I cap plus wf2 j cap dot product with nx I cap plus ny j cap. So any doubt till here? So if you have any doubt, please you can interfere in between. So I will clear it if you feel any doubt. So any doubt till here? You can intervene.
No, sir.
Okay. So I will continue. So if I expand this I cap it will be wf1 nx, then j cap will be wf2 ny. So this is a dot product of two vectors which has now scalar. So my boundary integral will be, this is going to be simply w times of f1 nx plus f2 ny into ds. So this one, instead of this term I am simply going to substitute this term. So effectively what I have done is I have converted this domain integral into a boundary integral. So this term I am going to keep it as it is. This term I am going to shift, I am going to rewrite now using the boundary integral. So what will happen? So find, I will get here over the domain f1 dw by dx plus f2 dw by dy into d omega minus over the boundary w times of f1 nx plus f2 ny into ds plus a00 into uw into d omega is equal to wf d omega. So this term, boundary term, I am going to bring it to the right side. So what I will get is, I will get some unified term like this, f1 dou w by dou x plus f2 dou w by dou y plus a00 uw. This whole integrate over the domain, this will be some w into f into d omega plus this boundary term. I will give some more space for writing, so I will start here, plus w f1 nx plus f2 ny ds. So we initially f1 and f2 we have just written it for the sake of simplicity. So we will now try to substitute this f1 in here. f1 is a11 dou u by dou x plus a12 dou u by dou y into f1, sorry, not f1, f1 we just wrote now, into dou w by dou x plus give some space for writing, for bracket be easier. So this larger bracket inside a11 dou u by dou x plus a12 dou u by dou y into dou w by dou x plus a21 dou u by dou x plus a22 dou u by dou y into dou w by dou y. Then you have plus a00 into uw, the whole thing multiplied by d omega. So this is one term. The second term is w times f d omega plus this boundary term I can expand now. It will be w times of a11 dou u by dou x plus a12 dou u by dou y into nx plus a21 dou u by dou x plus a22 dou u by dou y into ny, and this whole multiply integrate over the ds. Should be ny. So this whole term, these things, so I will represent it as qn for the sake of simplicity. So this qn represents the boundary term. Okay. So I will expand all the terms inside now. So a11 it will be dou u by dou x into dou w by dou x plus a12 dou u by dou y into dou w by dou x plus a21 into dou u by dou x dou w by dou y plus a22 dou u by dou y into dou w by dou y plus a00 uw. This whole thing integrate over the domain, you will get equal to w f d omega plus boundary, I will get w into qn into ds. So qn is nothing but this full term, I have simplified it. So again I will write it for the sake of simplicity once again. Qn is equal to a11 dou u by dou x plus a12 dou u by dou y into nx plus a21 dou u by dou x plus a22 dou u by dou y into ny. So this is the thing Qn. So after Qn, now what I am going to do, I have this formula with me. So dou u by dou x, dou w by dou x I have. So I am going to substitute what is u and what is w. So u I can write it as summation j is equal to 1 to n uj into psi j. So where n is the total number of nodes. So here n is equal to 3 since it's a linear triangular element. So which is nothing but u1 psi 1 plus u2 psi 2 plus u3 psi 3. Okay, and w is a weighting function which is also going to be same as my interpolation function but psi I. So if I substitute u and w, what I am going to get? We'll see one by one. A11 dou by dou x of summation j is equal to 1 to n uj psi j into dou psi I by dou x. So w is psi I. So if I substitute both are x, u and w, here dou u by dou y and dou w by dou x. So if I substitute, then a12 into dou by dou y of summation I equal j is equal to 1 to n uj psi j, and my dou psi I by dou x is going to remain. Is it correct? Yes. Okay, plus a21, this is going to be dou y by dou x, this is going to be dou psi I by dou y, and a22 both will be dou by dou y into dou psi plus a00 into summation uj psi j into psi I. This whole thing integrate over the domain. This will be equal to, in the right side you will have f times w, right? So f will be f as it is, f into psi I into d omega plus qn into psi I into ds. Okay, so this is my big equation. So what I am going to do here, you can say uj psi j. So my psi j, I can take it out of this this entire summation. This thing is common for all this term. And this uj is not going to be dependent on x or y because it's a nodal value. So it is not. These are all constants. So what I am going to do, the summation of j is equal to 1 to n uj is going to be common. So rest all is going to be inside terms. So integral a11 dou psi I by dou x into dou psi j by dou x. So I am going to split all the integrals into, so d omega I can write it as dx dy plus a12 into dou psi I by dou x into dou psi j by dou y into dx dy. So this is, then for a21 I can write it as this dou psi I by dou y into dou psi j by dou x dx dy plus a22 dou psi I by dou y into dou psi j by dou y dx dy plus a00 into psi I into psi j. This whole thing is there. Sorry, I missed the integral over here. Whole thing, then right hand side you have f into psi I dx dy plus you have the boundary term qn w psi I ds. Okay, so this entire whole term I can write as some stiffness matrix, right? So it's going to be some k matrix into u matrix, which is going to be some f matrix plus some q matrix, correct? Okay, so what is my f this thing? So a11, this will be something. So what if, so we can assume, so now what we can do is we can remove the a1 a12 a21 and a00, we can make it as 0. So what I am going to do, I am going to vanish these terms totally. a21 also I am going to vanish, a12 also I am going to vanish. So simply I am going to keep a11 and a22. So what is be my k matrix? Ki, I can say it's Kij. Integral of a11 dou psi I by dou x into dou psi j by dou x plus integral of a22 dou psi I by dou y dou psi j by dou y. So, sorry, I missed the dx dy. So if I take if I have the a11 and a12 are constants, so I can take a11 outside, so I can simply write it as dou psi I by dou x dou psi j by dou x dx dy plus a22 into dou psi I by dou y dou psi j by dou y dx dy. So this I can write as some function Kij is equal to a11 into Sij11 plus a22 into Sij22. So it is a sum of two matrices. So now how to find out? So till here any doubt? So we have just derived the stiffness matrix. Yeah. So I hope you are following closely. So yeah. So we will now we have this dou psi I, dou psi j and all. So what we need to do is we need to find out what is psi 1, psi 2, psi 3, and then we can take the differentiation. So what is psi 1? So for triangular elements we have already seen my psi is equal to, I will just simply go up. So psi is equal to 1 by 2a into alpha I plus beta ix plus gamma iy. Okay, so 1 by 2a into alpha 1 plus beta 1 x plus gamma 1 y. So here I am simply going to substitute. I am going to simply again write out x1 y1 is 0 0, x2 y2 is ax0, x3 y3 is 0b. So this comes from directly from the figure. You can see here, right? So this directly comes from the figure. My alpha 1 is going to be x2 y3 minus x3 y2, which is going to be x2 is a into y3 is b, minus x3 0 into y2. Alpha 1 is equal to AB. What is beta 1? y2 minus y3, which is going to be 0 minus b, so which is minus b. Gamma 1 is minus of x2 minus x3. x2 is a, x3 is 0, minus of a minus 0, minus a. So what is my, and my area is equal to half into base into height, so 2a is equal to ab, right? So psi 1 is equal to 1 by 2a is ab, alpha 1 is ab, beta 1 is minus bx, gamma 1 is minus ay, correct? So if I simplify this, it will become 1 minus x by a minus y by b, psi 1. Okay, psi 2, 1 by 2a times alpha 2 plus beta 2x plus gamma 2y. So what is alpha 2? x3 y1 minus x1 y3, x3 y1 minus x1 y3. x3 is 0 into y1 is 0, so 0, x1 is also 0, y3 is b, so 0 into b 0, so finally this is going to be 0. Beta 2 is going to be y3 minus y1, so it is going to be simply b, I think. You can check it. Yeah, y3 minus y1, b minus 0. And what is gamma 3? Minus of x3 minus x1 is going to be 0. So what is psi 2? 1 by 2a, 2a is nothing but ab into alpha 2, 0 plus beta 2 x plus 0, so this is simply x by a. So psi 1 I will highlight here, psi 2 I am going to highlight here, and now psi 3. Okay, a minute. Psi 3 is equal to 1 by 2a alpha 3 plus beta 3x plus gamma 3y. What is alpha 3? x1 y2 minus x2 y1. Again this is going to be x1 into y2 minus x2 into y1. This is going to be again 0. Beta 3 y1 minus y2. This is also going to be 0. You can check it here. y1 minus y2 0. Similarly, minus of x1 minus x2, gamma 3. What is x1? 0, x2 is a, 0 minus a is minus a, minus of minus a is plus a. So psi 3 will be 1 by ab into 2a is ab, alpha 3 is 0 plus beta 3x is 0 plus gamma 3y is ay. So this is going to be y by b. So we have found out everything. So psi 1, psi 2, psi 3 we have found out. So we are going to find out Sij11. Sij is equal to dou psi I by dou x, dou psi j by dou x into dx dy. Okay. So what is dose? Okay, so if you take it as 1 1, dou psi 1 by dou x into dou psi 2 by dou x into dx dy. So what is dou psi 1 by dou x? So psi 1 is 1 minus x by a minus y by b. Okay, we'll dou psi 1 by dou x is minus 1 by a, dou psi 1 by dou y is minus 1 by b. So here before here I will write psi 1, psi 2, okay, I will write near to the functions only. So here dou psi 1 by dou psi 2 by dou x is 1 by a, dou psi 2 by dou y is 0, correct? And for this dou psi 3 by dou x 0, because there is no term related to x, dou psi 3 by dou y is equal to 1 by b. So dou psi 1 by dou x, dou psi 2 by dou x, so it is going to be minus 1 by a into 1 by a. Okay, so this is going to be minus 1 by a square into dx dy. So what is dx dy? Is going to be area of the triangle, correct? So this will be minus 1 by a square into ab by 2, so which is minus b by 2a. S1111. Now I can find S12 of 11, dou psi 1 by dou x into dou psi, what will it be, dou psi 2 by dou x. So till here any doubt? So we are simply finding the value of the two matrices. So what are our two matrices? Sij11 and Sij22. So from I ranges from 1 to j, 1 to 3, and j ranges from 1 to 3. So each matrix we are going to find out. So what is my dou psi by dou x, which is going to be minus 1 by a, dou psi 2 by dou x is 1 by a. Okay, I think I made a mistake. So this will also be minus 1 by a, right? So because yes, this is 1 1, so this will be dou psi 1 by dou x into dou psi 1 by dou x. So this is going to be 1 by a square. So this is simply b by 2a. So why this means both are dou psi 1 by dou x, because I j both are 1 1, so it's dou psi 1 by dou x into dou psi 1 by dou x. So here it is going to be dou psi 1 by dou x into dou psi 2 by dou x. So minus 1 by a into, here this will be 1 by a dx dy. So this will be minus 1 by a square into integral of dx dy over the triangular element. So this will be minus 1 by a square into ab by 2. So this is minus b by 2a. So this is S12. So any doubt till here? So element by element we are calculating.
No, sir.
Okay. So what is S13? Dou psi 1 by dou x into dou psi 3 by dou x into dx dy over the triangle. So dou psi 3 by dou x, if you would have seen, it is 0. So this entire term vanishes. This becomes 0. So what is S21? Is equal to dou psi 2 by dou x into dou psi 1 by dou x into dx dy. So what is dou psi 2 by dou x? Minus 1 by a. What is dou psi 1 by dou x? Sorry, 1 by a into minus 1 by a. So this is 1 by a, this is minus 1 by a dx dy. So this will be minus 1 by a square into dx dy. So this is nothing but area of the triangle, minus 1 by a square into ab by 2. So this is minus b by 2a. So S22 will be dou psi 2 by dou x into dou psi 2 by dou x into dx dy. So this will be, both will be 1 by a, so it will be 1 by a square into dx dy. So this will be b by 2a. S23 will be 0 because dou psi 3 by dou x will be coming in the term, but dou psi 3 by dou x we have seen it is 0. Okay. So this is 0. Similarly, S31 will also be 0 because this also involves dou psi 3 by dou x, and this will S32 will also be 0. S33 will also be 0. So why these are 0 means this will involve dou psi 3 by dou x. So any term involving dou psi 3 by dou x will automatically become 0. So if I now put the S11 matrix, if I make it, so it will be of this form. So it will be b by 2a minus b by 2a 0. So this will be minus b by 2a, b by 2a 0. This will be 0 0 0. So this we did for S11. So what is Sij of 2 2? We saw that there are two matrices, right? So this is A11 S1 Sij corresponding to this, and this is respect to both y differentiation, Sij with respect to 2 2. So I can simply write, I'll quickly write it. So it will be sorry, I have to do it element by element, right? So S11 integral of dou psi 1 by dou y into dou psi 2 by, sorry, not dou psi 2, it will be dou psi 1 by dou y into dx dy. What is dou psi 1 by dou y? Is 0. So both are 0. So any term involving 1 will be 0 because dou psi 1 by dou y is always 0, right? Oh sorry, it is dou minus 1 by b, so I made a mistake, sorry. So this will be, this will not be 0, this will be minus 1 by b into minus 1 by b into dx dy. So this will be 1 by b square into integral of dx dy. So this will be 1 by b square into ab by 2. So this is nothing but a by 2b. Okay. So I made a small mistake. I mixed up with psi 1 and psi 2. So here I have the formula. Psi 1 is going to be psi 2. So this psi 1 into psi 2. Next. So this is going to be 0, this will vanish, so this will be 0. So S13 dou psi 1 by dou y into dou psi 3 by dou y into dx dy. So this will be minus 1 by b into, what is dou psi 3? That will be 1 by b. Into dx dy. So this will be minus 1 by b square into dx dy. So this will be minus 1 by b square into ab by 2. So this will be minus a by 2b. Okay. And S21 dou psi 2 by dou y into dou psi 1 by dou y into dx dy. So this will vanish, this is 0, because we already saw that dou psi 2 by dou y is 0, correct? Yeah, so dou psi by dou is 0. So 2 2 and 2 3 will also be 0, since it involves dou psi 2 by dou y, which is going to vanish. So now S31 dou psi 3 by dou x into dou psi 1 by dou x dx dy, this will be 1 by b into minus 1 by b. So this will be minus 1 by b square into ab by 2 minus a by 2b, sorry, minus a by 2b. Okay. And S32 will be 0 because it involves dou psi 2 by dou x. S33 will be dou psi 3 by dou x into dou psi 3 by dou x. What is dou psi 3? 1 by b. It will be dou psi 3 by dou y into dou psi 3 by dou y. I think here also this should be y actually. Okay. This will be 1 by b square into ab by 2. So this will be a by 2b. Okay. So finally we can summarize this S22 a by 2b 0 minus a by 2b. Second row was fully 0, and this will be so finally I can summarize Kij. Finally, it will be A11 into this matrix, the first matrix, minus b minus b 0. Plus A22 into a by 2b 0 minus a by 2b 0 0 0 minus a by 2b 0 a by 2b. So we have finally derived the element stiffness matrix. Okay, so any doubt in this question? This is a very long question. We have derived the element stiffness matrix. Any doubt in this? So how we derived? Okay, so we can simply evaluate. If you substitute A11 and A22 as k and A equal to b, you can simply substitute and find out. You can add then both the matrices. So we can go to the next question now. Okay, so this question: for a linear triangular element of area A with constant source f, the fraction of the total magnitude of the source on the element that is carried by each node is fa by 2, fa by 3, fa by 4. So can you guess what could be the answer? So for a linear triangular element, so each node it carries some source. So if f is your source, so each node will carry some value. So what will be the value at each node? Can anybody take a small guess?
Sir, fa by 3.
Yeah. So if you simply take the f into w into d omega, right? So this is nothing but f into psi I into d omega. and if you take your f constant, it is constant source, you can take f outside. Psi a is nothing but 1 by 2a times alpha I plus beta I x plus gamma I y into d omega, right? So if you try to evaluate it, you can see that this will turn out to be fa by 3. So how we are going to evaluate is alpha I, we can simply take it out. So let us say it's dx dy. So if you simply substitute everything inside, so you can take this 2a also outside, so it will be f by 2a into, and alpha I will also come out. Yes, any doubt?
Sir, yeah,
Yes.
relevant to this only.
Yeah.
I'm sorry, I have been listening,
Yeah.
but online means only bits are like this. We have to get descriptive type or what's for exam mode.
Exam it will be both type actually. So major part of the question will be like objective type, like this.
Okay.
Uh,
40 marks, 60 marks, sir.
you can say it is about 60 mark will be in the objective type. Then maybe 40 marks subjective type. There also you will be given one box where you have to enter the numerical value. So something like that.
Oh, numerical value. I have to solve it and do numerical value. I have to enter that box.
Yes. Like that you will
So
get.
is 60-40 or correctly, sir? Exactly.
Exactly, I'm not sure, but I think
The examiner will decide.
yeah. So last year I think
Approx.
it was 60-40 approximately.
Oh, so these 40 marks we should do descriptively in the rough work. They will
Yes.
provide papers.
Yeah, they will provide the rough sheet. You can do the calculation, and once you finish the calculation, you will get a final numerical value. You can just enter it in the box. You can type it in the box. That's all.
Sir, no negative marking.
I think there is no negative marking, I think.
Okay, thank you.
Yeah.
Okay, sir. Thank
Yeah,
you
yeah.
so much, sir. Okay, sir. Sorry for disturbance.
No problem.
I have been listening properly.
Yeah.
Thank you.
Okay. So if I simply, it will become integral dx dy. Then if I take beta I, it will become x dx dy. Then if I take gamma I, it will become y dx dy. Correct? So this x dx dy will be nothing but f by 2a into alpha I into a, sorry, plus this will be beta I into, so if you put integral x times of dx dy, you can find out, you have some standard integrals. This x times of dx dy will be nothing but it will become, give the value of x cap, and into a times of x cap, then gamma I you will get as y cap into a. So finally you can cancel all the a. So what you will get finally is f by 2 into alpha I plus beta I x cap plus gamma I y cap. So this already we saw, right? If you simply go to the previous question once, so we saw that this entire alpha I plus beta I x cap plus gamma I y cap is 2a by 3, correct? So if I put f by 2 into 2a by 3, so this 2 cancel, finally I'll get the value as fa by 3. So although it is very intuitive that it will be equally split in all the nodes, so by theoretical calculation also we are finally arriving at the value of fa by 3. So this is question 7. So I think we will see one more question, one last question we will see, because I think soon it's going to be 8 o'clock. So I think we will see quickly this question probably. So we have a linear interpolation function for rectangular elements. So rectangular elements we already derived the interpolation function, correct? So let us say that here my element is varying from 0 to a and 0 to b. So we can assume that in the xy, you can say this is our rectangular domain. So this is 0, this will be A and this will be B. So what they are asking, and we psi also we already developed. Psi 1 is equal to 1 minus x by A into 1 minus y by B. Psi 2 also we developed 1 minus this will be x by A into 1 minus y by B. Psi 3 will be x by A into y by B. Psi 4 will be y by B into 1 minus x by A. For the same setup, we can say this is the psi values. So you can simply calculate what is d psi 1 by dx, what is d psi 1 by dy, what is d psi 2 by dx, what is d psi 2 by dy, what is d psi 3 by dx, what is d psi 3 by dy, and simply you can keep calculate. So quickly I will do that. So d psi 1 by dx is equal to, you can say it is first of all you can expand it inside 1 minus y by b minus x by a plus x y by ab. So it will be minus 1 by a plus y by ab. So this is one thing. So next is d psi 2 by dx. So what is that? It will be simply 1 by a minus y by ab. I think this also we have calculated previously. So this will be y by ab minus y by ab. Then again dou psi 1 by dou y is equal to minus 1 by b plus x by ab. Dou psi 2 by dou y is equal to minus x by ab. I think dou psi 3 by dou y is equal to x by ab. Dou psi 4 by dou y, you can say this one minus x by ab, 1 by b minus x by ab. Okay, so what they are asking in the question, psi I into dou psi j by dou x. So I will just do for one element. You can simply do for rest of the elements and do the develop the matrix, right? So first I am simply going to do psi 1 into, so let us say s1, psi 1 into dou psi 1 by dou x, correct? So what is psi 1? 1 minus x by a into 1 minus y by b. What is dou psi 1 by dou x? Minus 1 by a plus y by ab. So this whole thing I am going to integral from 0 to a, 0 to b, dx dy, correct? So if I integrate this, so what will, so I will just first expand the first two terms, 1 minus y by b minus x by a plus xy by ab into minus 1 by a plus y by ab, integral 0 to a. So first you will have dx dy, minus 1 by a plus y by ab plus y by ab minus y square by ab square plus x by a square minus xy by a square b, then again minus xy by a square b plus xy square by a square b square whole thing dx dy. Is any term cancelling out? Yes, these two are cancelling. I think that's all. So first of all I can simply decide one term, then then minus 2 by a square b xy dx dy plus 1 by a square b square xy square dx dy. Okay, so this is the example for one element. So since it is taking too long, you can follow this what I have done here. You can do the double integral. So dx dy, it's simple. So how to do? For example, I'll just do this one integral alone. So rest of the integrals you can try on your own. So how to do y square dx dy, 0 to a 0 to b. So first you can simply integrate y. So y ranges from 0 to b. So you can say y cube by 3 from 0 to b. That will still be inside the integral. Then again 0 to a will remain. Then 1 dx will remain. Correct. So what is y cube by 3? So it will be b cube by 3. So this will come outside, integral 0 to a dx. So this will be b cube by 3 into x from 0 to a. So this will be b cube by 3 into ab cube by 3. So this is one way of doing the integral. So like this we have to do the integral for all these terms, and then calculate the one component, and then assemble the whole matrix. So this also I will skip now. So this question also we can skip because we do not have time. We will simply do the last question. So I have these two rectangles. I have a rectangular element of area A, and constant source f. Correct. What is the total magnitude of the source on the each an element that is carried by each node? So we have four options. So one is fa, second is fa by 2, third is fa by 3, fourth is fa by 4. So can you tell what could be the answer? So for triangle we saw previously. So what will be for rectangle?
Yes, sir, fa by 4.
Yeah, it will be fa by 4. So each node will carry the value of fa by 4. So if you calculate the fourth term, it will be simply fa by 4 into 1 1 1 1. So that's how it will be. So I think we will stop the session with here. So it's already 8 o'clock. So I hope there is no doubt in what we discussed today. So is there any doubt in the questions we discussed today?
No, sir.
Okay. So if there is no doubt, so we can close the session. So shall I close the session?
Yes, sir. Thank you,
Yeah. Okay. Thank you. So I will stop the recording as well. Okay, I will close the session. So we will see next week in the same time, 6 to 8. Okay, thank you.